Hello. Thank you for having me here. My name is Mark Bates. We're going to talk about rediscovering Go today. But just by way of introduction, like I said, I'm Mark Bates. You can find me all over the internets, GitHub, Twitter, Slack, go for Slack, as at Mark Bates. I'm not particularly creative when it comes to usernames, so there's that. This is also my custom Ashley McNamara Gopher avatar. So if you see that, please say hi. And if you don't already have your own Gopher avatar, you go to gopherize.me, GoPherize.me, and you can generate your own Gopher avatar. It can even look a little bit similar to that. The hair and the shirt is available there, but the guitar is just for me. Sorry. Ashley designed that just for me. That's all mine. But there are like 300 million combinations of stuff. So I'm sure you could put together your own avatar there. Anyway, I am a founding partner at a company called Go for Guides. We do Go training. So the last few years, we've been obviously doing in-person training, and I'm going to talk a little bit about that as part of this story here. But most recently, this year, we've switched to, well, we're pretty much 100% virtual Go training at this point, because let's be honest, folks, everything's virtual these days. Okay, so anyway, like I said, we do Go training, we do consulting. So if you're interested in any of that, please go to goforguides.com. And without T&E, things are even more affordable. Sorry, had to do the little plug, and my partner Corey would have killed me if I didn't. Um, but we're not here to talk about all those things that I like to do, like travel around the world and teach people Go, except I'm going to talk about just that in a minute. This is a talk about kind of my journey of rediscovering Go in the last year. Um, and I think, like all journeys, we're going to see hopefully some growth along the way. But my journey to rediscover and go really starts back in 2013 with my kind of discovery of Go. Back in 2013, I was making a living with Ruby on Rails. It was dominating my life. I had been using it since 2005, when it was pre 1.0. So I was a very early adopter of Ruby on Rails. And by 2013, I had written a book on Ruby. I was keynoting Ruby conferences. I was organizing the Boston RB meetup, which was itself a mini conference every month. We were selling out at nearly 200 seats every single month. I was, doing all these conferences where I was hosting, I was keynoting, I was doing kind of workshops like Ruby Bridge workshops and other sorts of things along those lines. So, and I built a successful consultancy as well as a video screencasting service called Metacast that was focused around Ruby on Rails. But that same year, out of the corner of my eye, this little gopher started appearing all over the place in my life and in my kind of news feeds and in my conversations with my fellow developers. And by the end of 2013, that gopher had taken over my life. Um, Go was all I wanted to do, and I was completely consumed by it. And those of you who know me know what happened next. I went on to write the Ruby on Rails for Go called Buffalo. And in addition to Buffalo, there were a bunch of other packages like Pop, the ORM, and Plush, which is like an ERB style templating language for Go. So, I brought what I knew with me from the Ruby world, and I built those tools that I needed and then I was so familiar with from that world. If I fast forward now to 2019, there are a couple big events that were happening in my life that started me on this journey of rediscovery. The first event was the adoption of Go modules. Now, in 2018, Russ first announced Vigo, which was kind of the beta version of what would become Go modules. And there was quite a bit of drama. I'm not going to rehash what 2018 was all about. But in 2019, that's when the rubber really met the road when we talk about modules. That's when we started actually implementing modules. Large packages started migrating to modules like Kubernetes, Buffalo, and others, right? But at the same point, there was kind of fires being put out everywhere in the community. There was a lot of tension. There was a lot of frustration at modules. And it wasn't modules kind of themselves anymore. We had gotten past whether they were the right or wrong solutions. It was just kind of the teething problems dealing with it. And thankfully, now a year later, I can say wholeheartedly that modules have come a very long way, and they're so much more usable and so much easier to use than they were just a year ago. So kudos to the Go team and everybody for making modules that much better in a year. But last year, we were really struggling as a community, kind of getting modules in place. So that was a problem I was having as an open source maintainer. I was fighting all these module related issues, and that's shown some light on my code as well that I'm going to talk about here in a little bit. The other big event that was happening in my life was I was traveling nonstop last year, kind of just hurtling forward. I think Chidi's face kind of says it all. That's kind of how I felt most of last year, right? I was traveling easily once a month, if not every other week, sometimes more than that. Between the trainings we were doing for Gopher Guides all across the country and the world, and flying over for that. And then the workshops and community events that I hold oh so dear that I've missed this year, like GopherCon and Gotham Go and GopherCon UK and GopherCon EU and all these other great, wonderful events that we're kind of sharing now online, such as this. But I was doing all that as well as the training travel. And then finally, my family loves to travel. That's kind of what we do. My wife's English, so we go back to England not quite often. We went twice last year. Unfortunately, we were supposed to go twice this year, and I don't think that's going to happen, unfortunately. We absolutely love traveling, and we went on not only that, but we had a couple family trips, smaller trips, not just the trips to England, but just other trips in the US and some other travel. So I was kind of all over the place last year. And that it threw a whole bunch of other problems at me. It kind of shone, again, light on different aspects of my code that would push me to this rediscovery. And I'm going to talk about that in just a minute. Obviously, that's kind of what we're going to talk about here. While all that was going on, the last 3 years, I've been along with Corey Lanou and Tim Raymond, building Gopher guides and writing training materials. Just a ton of writing and a ton of example code and kind of defining problems and really focusing on how do we present a specific topic in the smallest amount possible while still retaining some kind of useful value, right? How do we write these examples and how do we approach learning Go where we can build slowly on that and learn these intricacies of Go while we go. And of course, when you're traveling, so you write all of this, spend all this time writing. And as somebody who's written 3 books, I can tell you that when you start a project, like and say a book project, a blog post, or training materials, you go into it thinking that you have this cumulative knowledge. You've got all this knowledge. I'm so smart. I know it all. And what you really realize is you're probably, and you think, okay, I'm probably 70% there, and I'm going to fill in the other 30% when I'm writing. And the reality is usually true. The opposite is usually true. The reality is that you kind of go in, you only really know 30%, and you have to learn that other 70%. But when you come out the other side, you're just that much further along. And to give you an example of this, last year alone, Gopher Guides wrote 40 plus articles for DigitalOcean. on Go. And when I say on Go, I mean beginning Go. Whole articles on Boolean logic in Go, variable declarations in Go, comments. That was the very first one we put out was about comments in Go, and within an hour it had 5,000 views. Um, this year, just recently, DigitalOcean took all those articles and put them into an ebook, free ebook. I highly recommend you go and grab it. It's nearly 700 pages long. That's a lot of writing, and that's a lot of detail to understand as an author and as an educator. And then finally, when you're actually standing there in a room, or nowadays standing there virtually in in a room, as it were, you gain so much practical experience on the spot in the room. I go to these Fortune 500 companies and other companies all around the world, right? And they all have different problem sets. They're all focused on something completely different from each other. And so their questions and their backgrounds and their knowledge and the things they're trying to accomplish are so wildly different that you can't help but have to learn in that environment as an educator. And any educator out there will tell you that. You learn about yourself, and you learn so much about the subject the more you're in front of people, and the more you talk to them, and the more you take the time and you answer their questions, and you do kind of some live coding to try and solve their problems and understand it. And we take a lot of that in Gopher Guides, and those live examples that we code to show somebody something, to demonstrate. We take those, we kind of refactor them later, sometimes even that night at the hotel, and put them back into our training material. So we're constantly trying to improve those things. And in doing so, we're also improving ourselves, and what our conceptions of ourselves as developers are. And Corey will tell you this, and so on Tim. When we started, like I said, we thought we knew one thing, and we've now realized how much we didn't know, how much more we know now, and how much more we still don't know. But that makes you kind of introspective as well, right? Um, because as I was writing all of this, I was learning about Go and how to write idiomatic proper Go. And then I was faced with those other couple problems I was talking about. So let's bring those things back now, right? And let's talk about my conceptions of self, and what this kind of those are three events: Go modules, Go module adoption, me traveling all around the world, and finally the last 3 years of writing and educating and training I've been doing with Gopher Guides and at conferences and all over the place. What When I put all these things together, I found that I was in these hotel rooms, right? Here's the story now. Here's where it all comes together. I'm in these hotel rooms all around the world, or I'm in the restaurant, at the bar or the restaurant at the airport waiting for my flight. I have small snatches of time to work. That's the travel problem, right? That's what travel does to you. It gives you limited focused amounts of time. I didn't have 40 hours I could sit at a comfortable desk in my house on my big screen computer with my nice mechanical keyboard and all the luxuries that go along with working at home, right? I didn't have that. I had my 13-inch laptop in a hotel room after I've been training all day. So my time is limited. I had modules pressing on me, right? I had all these bugs I'm trying to fix. Um, and while doing this, I started looking at my code, and I started to understand and identify my code and problems in my code. The first and most kind of egregious is that it's very non-idiomatic. I look at a lot of the packages for Buffalo, excuse me, that I wrote very early on, and I broke one of the major rules I give to all of my students. When I'm teaching Go and I'm talking to people, I always tell them not to code Go in their previous language, right? Don't code Go like Java, which a lot of people do. Don't code Go like Ruby. And that's what I did. I came in and like I said, I wrote the Ruby on Rails for Go. And I wrote it like Ruby. And I wrote it like Rails because that was what I knew at the time. And that was how I knew to code. Um, but those patterns and a lot of those concepts are not idiomatic at all for Go. They might be for Ruby, but they're certainly not for Go. Um, the code was complex, and part of that stems from that non-idiomatic part of it, right? Where because it's non-idiomatic, it's just more complex because it's kind of going against the grain of the language. But a lot of it also had to do with um, again, my own beginner's instincts in Go, me kind of bringing over what I knew, which was Ruby, and some Java and Java before that. And some of it was kind of needing to get this done today because I need this feature for Buffalo so I can finish this project I'm working on. I need this thing, there's this bug, or this problem, issue, whatever it is, right? So that kind of unarchitected code becomes complex and crufty over time. Um, I have dependencies all over the place, and Buffalo is notorious for being quite dependency heavy. And we've been working on that over the last year, pulling that down, and we still have a lot of work to do. I'm well aware, and all of the team knows that as well. But we're certainly working towards lessening that. But at the time, last year, we had tons. When you take those kind of heavy dependency trees, and we had dependency trees where, Buffalo would pull in, let's say, a package like Packr, and Packr would pull in Jenny, and Jenny would also pull in Packr, which pulled in Jenny, which pulled in Packr, and each one was a slightly less of a release just because of the way modules works, right? So you'd end up downloading the internet. Now, thankfully, again, they've solved that problem, which is a load off. But fighting that module dependency tree was a big problem uh, in my code. Um, my code was hard coded all over the place for all sorts of different things like pop and webpack and plush and a bunch of those other things I had talked about earlier. They weren't loosely coupled like they should be, right? They weren't easily swappable, and that's again because of just the time, the inexperience, right? The lack of understandings of the correct patterns to use and Go kind of forced me to just say, well, I'll hard code this in here and I'll figure it out later. Um, and when you start putting all that together, you start ending up with a lot of spaghetti code and a lot of poorly tested code as well. Um, and then, of course, last year we had the Go path, we had modules, we had dep, we had glide, we had all these kind of uh, package managers slash non-package managers out there, right? And so it became difficult. I had all of this to deal with. I had modules beating me down because of all the dependencies and the like. And every time I felt like I was fixing one dependency issue, it was like whack-a-mole, another one would pop up in a different module somewhere else, right? And I had no time. I had, like I said, an hour here, an hour there, a couple hours here, a couple hours there, in a restaurant, in a bar, in an airport, on a plane, right? Not perfect hours. They weren't those nice sitting at my desk with a cup of coffee hours. And I found that when I was trying to fix problems, when I was trying to, whoops, sorry about that. There we go. When I was trying to fix the problems, um, I found myself caught up in the keynote. Here we go. Voila. Sorry about that. Like I said, when I found myself with those limited time crunches trying to fix these things, I was frustrated and I was getting angry because I couldn't get into the problem quick enough. right? The time I would spend just to even find where the bug was in the code, I would run out of time, right? I'd have to board my plane, or it was time for dinner, or I had a meeting, or whatever the thing was because of all this travel I was doing. I became angry and frustrated, and I knew I needed to change. So, what I'm going to talk about now for the rest of the talk is some areas that kind of highlight where I'm changing and where I'm trying to place my emphasis, right? And hopefully show you that we can all learn, we can all grow, we can all kind of rediscover ourselves, and hopefully too, I'm going to show you a couple decent little patterns and things that might help you in your code too. So let's start with modules, because this was, like I said, one of those triggering events for me last year that made me start on this journey of self-discovery. Um, it was thorny, it was prickly, it was just downright unpleasant. Let's just put it that way. It's downright unpleasant. And so, I knew that there were a couple things I needed to do. One was obviously reduce dependency count, right? I needed to stop depending on the whole universe. That was a very Ruby on Rails model and still is, right? If you ever looked at a bundler file, a gem file, in a Rails app, it's massive. And that's fine. That's the way they want to build Rails. And that's the way I initially built Buffalo. And I want to change that. And I want to make Buffalo a lot lighter, a lot leaner, and only pull in the dependencies you want. And unfortunately, I don't have the time in this talk to talk about plugins, but I have an entire other talk that I gave earlier this year for GopherCon Russia, which I definitely recommend if you're interested in watching, as it talks about plugins and interfaces and goes deeper into CLIs as well. But anyway, back to modules. I said I definitely knew I had needed to reduce module count, but the other thing I needed to do was kind of just buy into it wholeheartedly and say, okay, modules are here, they're going to stay, so I'm just going to bite the bullet, buy into it early, and call it a day. And I mean, I had done that originally by using Vigo right from day one in 2018. But I meant this now for Buffalo. So as of January 1st this year, we stopped supporting anything other than Go modules. If you weren't using Go modules, you can't use Buffalo. It just wouldn't work. So we took that step and we bought into that. And by doing so, we could start making use of some of the tools that, and by we, I mean I could start making use of some of these tools that modules give us. So as a quick kind of example, when you're working in a Buffalo app, when we're writing tooling for Buffalo, before modules, there was no concept of a project folder for Go, right? There was just the Go path. And so we had a lot of code trying to determine, are you in the Go path? What else is in the Go path? Where are you in the Go path? Are you in a Buffalo project? Are you not in a Buffalo project? It was very hard to tell. And so a lot of the tooling, like that early tooling, especially like Packr and stuff, that was built around the Go path, had to try and do a lot of guesswork to understand and figure out where it was, where it needed to be, and what it was doing. But with modules, we now have this sense of a project, right? We know a module's root is where its Go mod is. And so with the Go tooling, we can find out all of that information. So for example, if we use the packages package, sorry, I didn't name it, I just use it. It's one of those Golang org X tools packages. If we look at just the quick structs here, you can see all the useful information we can have, right? Package path. So this is like, github.com/go buffalo, right? The Go files in that package, right? All the .go files, other files, test files. We can get imports, right? So this package, what does this package import? And if you can imagine writing the tooling that you need to write for projects like Buffalo, knowing the imports and knowing what files are there, and you getting access to the AST information, the types information, and the module itself. We can ask for the module, and when we look at that, we can get things like, well, where's the Go mod file? Is this a main package that we're currently in? What directory is it? Where on disk do I find this? Which Go version does this rely on? Um, right, that's so much information, and if you're curious how hard it is to get this information, not very at all. And that's what's so wonderful about it. We import the Golang package, and then we can just we can create a new packages config, and the mode here tells it what kind of things we want to pull in. And there's a ton of different things we pull in. In this example here, I'm pulling in the need module mode. So that's going to give me back the module information, need name, which kind of gives me name and package path and a few other bits, and need imports. And that's going to tell me all the import information. Now, there's more I can pass in here and keep kind of appending these modes, but that's good enough for this example. In fact, I don't even need the need imports call because I'm not using it in this example here. But then I can, using the packages package, load using that config, I can then load, in this case, github.com go Buffalo render, which is the render is a sub package of the Buffalo module. So I'm not even asking for the root module, I'm asking for a sub package in a module somewhere. And the reason this returns back a slice is because there is some basic pattern matching in the packages package. Again, I didn't name it, I just use it. But I'll let you read the documentation there. For our example here, just the one package, we're only kind of expecting the one package back. And if I run this, what I end up with is kind of this output here, where I get the name of the package, which is that Buffalo render package. I get the location of the the Go mod file on disk, which, as you can see, is in my Go path, pkg mod cache download, right, all the way down there at the very end. I can get the location of the actual module on disk. Under Go path pkg mod, if I follow that all the way down, I'll find all of the source files for Buffalo version 0.16.10 there, right? They're all going to be there. And then finally, I just got the actual version information itself printed off. So there's a lot of useful information there that, as a tool author, I can easily build upon if I buy into the concept of modules. All right, so by adopting kind of a modules only approach, right, I'm no longer fighting the Go path, right? I've got this accurate understanding of package and module data and imports and AST stuff. I have accurate file path information. No matter where I am inside of a module, I can easily find its root programmatically, right? I can ask for the package and I can find its root very quickly and easily. I can get rid of all of that code that was dealing with the Go path and dep and trying to figure this all out and make sense of it all. Okay, so let's now quickly look at CLIs. I build a lot of CLIs, and I've been spending the last year working very deeply on the Buffalo CLI, and we're going to touch upon that here a little bit. Right, so let's take a stroll down Main Street here and think about how we write our applications, right? We know that our applications have to start in our main function in the main package, usually in a file called, well, main.go. So when I talk about this, I often talk about main.go. And when I say main.go, what I mean is just that, the main package, the main function inside of the main package. But it's often just easier to talk about that. In Buffalo, we use the Cobra package, SPF 13 Cobra, originally written by a very good friend of mine, Steve Francia. And it's a wonderful package, and it really allowed us to bootstrap, and again, by us, bootstrap the Buffalo CLI at the very beginning. of this whole thing. And you know, we've then kind of tried to hack things like plugins onto it. And again, I'm not going to talk about plugins in this talk, but I would refer you to my GopherCon RU talk earlier this year on that if you're interested in plugins and interfaces and CLIs. So we were using Cobra. Now, I don't expect you to read this code here. And that's kind of on purpose. This code, what this code is this is the code for the root command in Buffalo. So if you go to the main.go in Buffalo, it points you at a package called CMD and an execute function, which is that kind of second to last function there at the bottom of this source code. And that does stuff that all that does is call a global variable called root command and calls its execute function, which is nowhere to be found in the source code at all. So somebody coming into this now, like myself earlier today, and I'm like, well, where does this actually all hook up? How does this work, right? This code is confusing. And again, I'm not blaming this on Cobra. I'm just blaming this on kind of when you start using something like a Cobra in a large code base, this is kind of what ends up happening. We end up with this very confusing code. Like I said, the point of entry is not clear. We have global variables all over the place. Every command is a global variable. We have options as global variables, all sorts of different things. They're very difficult to test. I mean, where do I even begin as a developer testing this? It's not clear, right? And this sort of code leads to kind of scattered and spaghetti code. At least it did for us. And there's kind of just more. It's, you know, and it's not very idiomatic and it's not very clean. I mean, we're using global variables to create some pointers, and then we're using functions inside those pointers and defining things like uses and whatever. It's a wonderful, Cobra's wonderful, but we outgrew it. I outgrew it. And the other reason why was it pulls in a lot of dependencies, has a lot of dependencies. And again, when I'm trying to think about my dependency count, I have to ask myself, is a CLI framework worth the extra dependencies that it's bringing to these projects? And ultimately, I think it does not. It served us well to bootstrap, but now I don't think it serves me well. At least in the tooling I'm writing, it doesn't serve me well. And using just the standard library and some nice kind of techniques, we can write these CLIs that are easy to follow, test, and understandable. So I've kind of gotten into this thing where I just like to keep my main as simple as possible. And so I've been working, as I said earlier, on the V2 for the Buffalo CLI. And this is kind of a snapshot of what it looks like to use it inside of a main function here. And I'm just going to zoom in just a little bit on two lines there. And those are the lines that create a new zero value pointer, the Buffalo struct from the CLI package. I'm going to show you what that looks like in a second. And it also shows the main function. There's a main function on the CLI, and that's all we're doing here. If this main function, this main.go we have, is creating a background context, getting the present working directory, creating a zero value pointer to a CLI type, and then calling that main function with the context, password, present working directory, and the arguments, right? And what we've done now is we've taken our CLI and we've made it an API, right? We now have this nice, easy to call CLI system. Here is the actual Buffalo V2 CLI struct. It has one public field, which is just a slice of plugins. And again, I'm not going to get into plugins, but in case you're curious, a plugin is an interface for any type that has a plugin name function that returns a string, and that's it. So even that is incredibly simple. But this main function here, I mean, look how incredibly simple that is. Context, root, and args, right? So if I want to write a test, here's my test, right? I'm going to create a temp directory. I can create a background context, and some CLIs. Sorry, some arguments for my CLI, in this case, new, Coke, and the -F flag for force, right? A zero value Buffalo struct, and then I just call it and, and give it that context, that directory, those arguments, so I could clean that whole directory up when I'm done, which is what I'm doing here with the OS remove all, right? But I'm giving it all of the information it needs. I can cancel the context in my tests, right? And not only can I do this from tests, I can do this from my main.go file, and you could do it too, right? So if we start writing our CLIs as APIs, right, they become a lot easier to write tests for because we can give them that kind of basic information that every CLI needs, which I've found to be the context, kind of the root, where am I operating from, what directory, and a slice of arguments. And that has driven the Buffalo V2 CLI a very, very long way. And again, if you're curious, I recommend that talk because it talks all about CLIs and using these techniques. It's a much deeper focus on this particular part of this talk here. But anyway, they're a lot easier to test. It's very easy to incorporate these CLI in non-CLI projects too, which is kind of cool, right? So you can take the V2 Buffalo CLI and you can put it in your code and you can use it and build your own kind of Buffalo CLI if you wanted to, for example, right? It's just programmatically callable. You could write a web app that takes JSON requests and pass it into these sorts of APIs, right? These main functions. When people are coming into your projects, right, it's clear to them what's happening. This is my struct. This is my main function for it, right? It's easy to instantiate. I have a nice public API versus a private main package. And ultimately, I think it leads to a lot more cleaner code. When people have that, put all their stuff in main, you end up with a lot of global variables. You end up with code scattered all out that main package, most of it not tested as well. But by putting it into like a CLI package, giving it a structure, giving it a function like that, it feels more like everyday Go code. And when it becomes everyday Go code, you're more likely to test it and you're more likely to write it like all of your other packages and APIs. So let's now talk about API design here. And this is going to be the last kind of area that I'm going to talk about. So design is very important. You don't want to end up with a situation where you have a bunch of scary clowns putting you to sleep every night, right? So I'm going to show you an example here of a tool called Packr. And what Packr does, this is, again, a Buffalo project, and it embeds static files into Go binaries. And you've probably used it or something like it, Go bin data, static, by JBD, a few others as well. But here's kind of the interfaces and types associated with Packr, right? It was a few different random interfaces, and they're not quite straightforward. If we compare that with, say, the file interface from the standard library, they barely have anything in common. And I can tell you for a fact that in Packr, things like the stat function, which claims to return OS file info, returns a mock info that is barely correct. So, I'm not a big fan of Packr. I know I wrote it, but we're going to talk about what I ended up writing that I'm a much bigger fan of. Right? We have these kind of impedance mismatches in something like Packr. So look at this quickly here, this code. I have to create a new box. Right? I give it a name, I give it a folder. And again, trying to place this relative string to the correct package in Packr is fraught with all sorts of issues. And then the actual using of it is kind of awkward. It's not a familiar API. I can find a string, find just gives you bytes. And a walk function takes a path and then takes a file, a packd file. Uh, that doesn't look anything like the standard library for working with files, right? In the OS package and in the file path package, right, we have these nice create methods that return files and make dir all and open and whatever, and we don't have any of that in the Packr side. Um, but what if we could write a tool like Packr that followed the path of least resistance, that looked at the standard library as a model for how to work with these things. So last year, I went and released a new tool called Packager, and Packager is a static file embedding tool, and it's a replacement for Packr. And if you read the blog post, I kind of say at the very end, I've washed my hands of Packr, and it's Packager from here on out. And Packager is built on the idea of modules, and I'm not going to go into that at all really here, but look at the file interface for Packager here. Well, it looks surprisingly like the file type for os.file, and that's not a surprise. That's on purpose. An os.file implements the file interface here. Right? I have this model. Why not use it? Right? I can keep things basic, keep things simple, right? A packager, the packager interface is kind of what represents the file system, right? So normally be, say, a disk-based file system, which is the OS package, or a memory-based file system, which is kind of what packager adds when you bundle it all up. But if we compare the packager interface to the OS package and the file path package, you can see they're identical. There's no difference between working with these two. That means when you go to adopt a tool like Packager, right, it feels comfortable and it feels familiar to you. Because for the most part, you can replace OS dot with Packager dot, right? And your code just keeps reading the same. All right, at first glance, this looks almost identical to code you would use the OS package for, and that is entirely on purpose, right? By offering familiar APIs, and by modeling the APIs found in the standard library, it's just so much easier for people to use our packages and to use our modules, right? Someone coming to use Packr has to learn a new walk signature. They have to learn how to access files. They don't get back the same information that they're used to getting. Whereas somebody with the OS package, but somebody who goes to use Packager, for example, comes in and goes, oh, okay, that makes sense. I already know that. I know how do I stat a file? Oh, I use stat. How do I make directory? Oh, okay, and I give it permissions. Okay, that makes. How do I create something? How do I open something? What does a file look like? What's the file info look like? And the file info in Packager, by the way, is 100% correct. So if you're looking for accurate file information in your static embedding tool, Packager's the tool for you. But this isn't, I'm not trying to sell Packager. Okay, so we're running out of time here, unfortunately. So let's kind of just recap what that discovery, some of the things that came for me from this discovery here, right? Rediscovering of Go, my codescence, if you will, right? By embracing modules, I was able to rid myself of, like I said, a lot of code and problems around GoPath and dep and other stuff. But I was also able to gain access to advanced tooling through tools like the packages package, and more accurate information and more data about what I was trying to do, because I bought into the way Go wants me to deal with my files and my packages through this modules system, right? We talked about taking a CLI from the main package and creating APIs out of it that are simple and easy to use and easy to test. And this has made my life so much easier. Just this one thing where my CLIs are these nicely cleaned up, simple interfaces um, that are easy to test and easy to work with. And you know, the Buffalo V2 CLI is so much further advanced and so much more capable and so much more simpler than the V1 because I use basic idiomatic Go patterns and made APIs out of my CLI as opposed to just throwing it all in main and just pretending it's a CLI and nothing else. And finally, we talked about the idea of mapping familiar API designs, right? Stealing them from the standard library. It's okay. They don't mind. I hope. Fingers crossed. But by using the standard library as an API reference point, I was able to gain a much better clarity on my code, um, much better understanding, and just this instant familiarity. I didn't say that correct, but you got the point. Right, this kind of instant access to that code from somebody who's never seen it before. They just kind of come in and go, "Oh, okay, this feels comfortable. This feels familiar to me." Right. So those are just a few of the ways that I've kind of been rediscovering Go over the last year through these couple different things. I mean, there's more, and I would love to talk to you about it, but I feel like I'm already running over. So all I'm going to say is thank you so much. I really appreciate your time. I want you to stay safe, wear a mask. I love you. I miss you all. And hopefully we can all see each other again soon. Bye.